In this module, we will see inbuilt functions that are available in the Python. Now, to understand what are inbuilt functions, let us see our calculator. In our calculator, there are so many buttons. Behind every button, there is a lot of calculations going on. So, you just imagine that these functions are nothing but those buttons that are available in the calculators, and those buttons, those functions, they are very handy when we are going with a huge amount of calculations. Now on the screen you can see there is a picture of calculator and there are so many buttons. So let us understand one by one every button. So you can see over here there is a power button over here. So similar to this power button, we have a function which is called as power function in the Python. So let us execute one program to understand this function. So I'm just writing print in bracket. I'm using power. So I'll say POW in bracket. Let us say I want to have 3 to the power 2. That means I am trying to print the value of 3 square. So if I run this, I am going to get output. The same output can also be done with the help of a double star operator. So here I don't need this power function. Okay, let me delete this, and if I execute this one more time, I'm going to get the same output. The difference between this print statement and this print statement is that in this print statement we are using a operator, and here we are using a function which is called as power. Similar to power function, there is a function to calculate the maximum, there is a function to calculate the minimum. Let us understand both the functions. So I'm just writing print in bracket. I'll say maximum of, let us say I'm writing some random numbers, so 12, this and this. So now if I execute this, I'm going to get the maximum number which are given in the bracket. So here you can see the maximum number is 79. So irrespective of how many numbers you are entering, it is going to calculate the maximum number. The same function can be replaced. In place of max, you can have minimum. So we can get the minimum value out of these 5 values with the help of this minimum function. See, I am going to get the minimum as 12. So from these 5 numbers, the minimum value is 12. There are other functions as well. Let us see. So we have the one more function which is called as round off function. So let us understand this. Here I'm just writing print in bracket round round off, and here 22 by 7, which is the approximate value of pi. So here if I print this, I am going to get the value of 3. If you print simply 22 by 7, then you are going to get 3.142859. This is a bigger number. So this bigger number is now rounded off, and the part which is there after decimal portion, this is completely removed, and you are going to get only the integer part. So this is the use of this round off function. Now there are other functions as well which are available in the library of Python. The function, it says absolute value, then division modulus and the summation. So let us understand one by one. So let us say I want to print a negative number. So print negative number, let us say -3. I am going to get output as -3. But if you put this in an absolute form, so I just need to say ABS. So what ABS function will do, if the number is negative, it will convert this into a positive number. So it is going to give you an absolute value. There is one more function which is called as division modulus. Let us try this. So I'm just writing print. Say if I go with 22 by 7, I'm going to get output as 3.14. But in place of 22 by 7, now I'm going to use a division modulus. So I'll just simply say DIVMOD, and in place of slash, now we have a bracket. So if you execute this, I'm going to get division modulus as 3 and 1. There is one more function which is called as summation. So basically this summation function is going to give you sum of all the numbers which are given in the rectangular bracket. Let us understand this. Here I'll just simply say print in bracket summation of, then we have a set of numbers given in the square bracket. So let us say I'm just writing 1, 2, 3, 4, 5, 6, 7, 8 and 9 and 10. So basically what this function will be doing, it will add all the numbers which are written in a square bracket separated by comma, and then it is going to give me the summation of all the numbers right from 1 to 10. So the summation is now 55. In Python, there are some constants as well. Like in your calculator, we have a button which is separately given to display the value of pi, and further we can use this value of pi in your calculations. So these are called as inbuilt constants. These inbuilt constants are also available in the Python, but in order to use those constants, you have to import a library which is called as math library. So math library not only holds the constant values, it also holds some standard scientific functions. Before that, let us understand the constants. So the very popular and very useful constant is pi. So if you want to use this pi in your calculation, you have to just type math.py. But since you are using math library, first thing is you have to import the math library. So let us try this in Jupyter Notebook. So here I'm just importing the value, I'm just importing the math library by typing import math. So once I execute this, what will happen? All the functions, all the constants that are available in the math library, they will be now available for us. So now if I say print math.py, so since I have already imported math library, now math.py, it is going to show me the value of pi as 3.1415 and so on. Similar to this, we have some other constants like e, tau and infinity. Let us try this. So here I'm just copying this, pasting it over here. Now let us see what is the value of e. So if I run this, so I'm going to get the value of e as 2.7182. Similar to e, we have one more function, one more constant called as tau. Okay, so if you execute this, you are going to get this particular value. Now there are other constants as well, that is infinity and not a number. In most of the engineering calculations, these constants, they may not be required. But in math library, there are also inbuilt functions. So we will be needing these functions very frequently in our calculations. Now the first set of functions that are available in the category of rounding of functions. So there are three functions that are available in the math library. The first one is ceil, second one is floor, and third one is truncate. So ceil function, basically it converts a number on a higher side. For example, if you write math.ceil 4.2 in a bracket, so 4.2, it will be rounded off into a higher side, and as an output you are going to get output as 5. Let us try this on Jupyter Notebook. So I'll just simply say print math.ceil, and here I am writing 4.2. So see, I am going to get output as 5. Similar to this, there is another function which is called as floor. But what floor does, it reduces the value to a lower value. Unlike ceil, ceil is rounding up the value on the higher side, but the floor is reducing the value on the lower side. Let us try this. So I'm just copying this, pasting it over here. I'm just replacing FLOOR over here. Now if I execute this, so the output is now 4, because this 4.2 number is rounded on the lower side, whereas in ceiling we have rounded off these numbers on the higher side. There is one more function which is called as trunc. So the purpose of this trunc function is to truncate a number. For example, if I write math.trunc 4.9, so what this function will do, it will truncate all the numbers which are there after the decimal part. Let us try this. I'm just replacing this trunc. So it is going to truncate all the numbers after the decimal point. As a result of this, you are going to get only 4 as a output. Apart from these rounding of functions, there are other functions that are available in the math library. Let us see. So these are some special functions. The first function in this case is factorial number. So if you want to calculate the factorial of, say, number 5, you just have to type math.factorial in bracket 5, and output you will be getting as 120. Let us try this. So I'll just simply say math.factorial, and I want to calculate the factorial of 5. So if I execute this, see I am getting output as 120. There are other functions as well that are very rarely used in engineering calculations like GCD, ERF, ERFC, gamma, L gamma and other things. Apart from these special functions, we have check functions. So this check function is going to check the type of a number. For example, math dot is finite. So it is going to tell you whether the number which is given in the bracket is a finite number or an infinite number, right? So this is going to give you finite. If it is correct, then the output will be true, and is infinite. So if number is infinite, then it will print true, otherwise it is going to print false. There is one more function, is nan, that is not a number. So if any value which is there inside which is not a number, in that case it is going to tell you the output as true, otherwise output will be false. Now coming to power and logarithmic functions. So we have one more category which is called as square root. There is a power, there is a exponential, log to the base 10, log to the base 2. All these functions that are available in the math library. So let us try one by one. Let us say I want to calculate the square root of say 5. So I just need to write SQRT, square root of let us say 5, or I should say 25. So if I run this, I am going to get the square root of 25 as 5.0. This function will also allow you to get the square root of a decimal number. Let us say if I want to know what is the square root of 2.5, so it is going to tell me square root of 2.5 is 1.5811. We have already seen a power function. Apart from that, there is an exponential function, log to the base 10 and log to the base 2. The syntax is very simple. You just type math.exp. If you in bracket you write 1, you are going to get output as 2.718. And if you write math.log, in bracket you have 10, your output will be 2.3. So you can try exp log 10, log 2 in Jupyter Notebook later. Apart from this, we have very commonly used functions, trigonometric functions. It is very much essential in our engineering calculations. So we have sine, we have cos, we have tan, and in order to calculate the inverse of sine, cos, tan, all you have to do is just write a just before sine. So a sine is going to give you sine inverse, a cos is going to give you cos inverse, a tan is going to give you tan inverse, and this is a tan 2. So let us see one by one. Let us calculate first of all sine. So here I am pasting this once again, math dot sine of let us say 0. So if I use sine of 0, so output will be 0 because sine of 0 is 0. Now if you try to have sine of 90, see what is happening. So sine of 90 degree, it is coming out to be 0.89399. This is an incorrect value because if you use a calculator, you are going to get a different value. Let us see. So here I am writing 90 and then I am using a sine. So sine of 90 is coming out to be 1 over here, and in this case I am not getting the correct answer. Now why this is happening? The only reason this is happening is the unit of angle. Right now in this calculator you can see the unit of angle is degree. But now if I change this to radians, and now if I type 90 and then I calculate the sine, see I am getting the same answer. So the meaning is Python using Python, whatever angles you are giving, it should be given in the radians, not in the degrees. So this can be done for cos also. So in place of sine, now we can have cos. So cos of 90, if you see, cos of 90 is coming out to be minus 0.48448. This is incorrect answer because if you see 90 and if I use degrees and then if I use a cos, see I am getting cos of 90 degree is 0, but whereas here cos of 90 is coming out to be negative. Again the reason is simple, because Python is treating this 90 as the value which is given in radians. So if you convert this into radians and if I say 90 and then if I use cos, see I'm getting the same answer. So basically whenever you are using a trigonometric functions in the Python, you have to ensure that whatever values you are giving, this should be in the radian mode. So let us try this one more time, and this time I am saying sine of 90. I want to convert this into a radian value. So I just need to multiply this with math.pi. Just now we have seen this is a constant divided by 180. So now if you execute this, so see sine of 90, which is ultimately getting converted into a radian. So I am going to get the value as 1. Let us try this. So 90, okay, and this time I am using a degree, and if I use a sine, see I am going to get the same answer. You can see similar behavior in cos as well. So if I use cos, now this time I am using cos of 90, then I am multiplying it by pi by 180, so that I should get the value which is over here in the radian form. So if I execute this, so see I am getting 6.1 something something and 10 to the power minus 17. So this is a very small value. So we can say this value is closer to 0. If you see the calculator, so 90, and if I use the cos value over here, so see I am getting 0. This is very close to 0. Now always remember that this has to be converted into a radians before using in sine, cos or tan functions. Now one way of converting is you take the value in degrees and multiply with math.pi divided by 180. This is one way, or you can use another inbuilt functions. Let us see. So there are two functions which are available for angular conversion. One is in degrees and one is in radians. So what degrees function does is whatever value is given to you, it is going to get convert into a degree, and in radians what it does is whatever value you are giving, it is getting converted into radians. So let us try this in Jupyter Notebook. So I am just using print, say math.radians radians. So in radians, if I write say 10 degrees, so 10 degrees is now equivalent to this much of radians. So if you use the same function in printing the sine or cos values, so I just need to include this in one more bracket, and then I'll say math dot say sine of this. So now if you execute this, so what it will do is your 10 is in degrees, so this function is going to convert this 10 into radians, and this math function, math sine function, it is going to calculate the value of 10 degrees which is getting converted into radians. So let us see. Here if I write 10 and this is in degrees, and if I say sine, so see answer exactly digit to digit it is matching. So always remember, before using sine or cos or tan, you have to convert an angle in degrees to radians. Now let us calculate the inverse of sine 0.1. I am taking the value of sine as sine inverse of 0.1 because the sine value or the sine value basically it is between 0 and 1. So to calculate the inverse of sine of 0.1, so I just need to write print math dot, in place of sine now you have a sine, that is the sine inverse, and I just need to write 0.1. So let us see what output I am getting. So sine inverse of 0.1 is coming out to be 0.1011. So let us check this value with the calculator. Now if you open the calculator here, let us say I am writing 0.1 and I want to use the inverse of sine. So I will be using second of sine inverse. So the value coming out to be, that is 5.739. Now you can see there is a difference between the values because the sine inverse value which is given by the Python, this is in radians, whereas the sine inverse which is given by the calculator, this is in degrees. So the thing is, whenever you are dealing with angles, Python or almost every programming language, it deals with radians only. So the output which I am getting here, this is basically in radians. So now I need to convert this in degrees. So if you want to convert this into degrees, the way of converting this is you just multiply this with 180 divided by, you say, math dot pi. So now if I execute this, so I am going to get output as 5.3917, which is exactly similar to the value which I am getting from the calculator. Now another way of doing inversion with angle in degrees is you just convert this output with the help of a function which is called as in degrees. So I just say math dot degrees degrees, and here whatever output you are getting, it will be converted into degree and then finally it will be printed. So if you execute this, you are going to get the same answer and you can find the same answer in the calculator. So always remember, whenever you are dealing with any angles in your engineering calculation, make sure that you are giving input in degrees or radians. If it is given in degrees, you please convert it into radians, and if you are using sine inverse or cos inverse or tan inverse, your output will be always in radians. So before printing, please ensure that you are converting this into a degree so that it can be used for the further calculations.